This is lesson 4, variables on both sides of the equation. So the key thing here is that we're going to have variables both on the left side of the equal sign and on the right side of the equal sign. All of the same undo rules apply. In order to get rid of 4x on one side, you would subtract 4x from that side, etc. The goal is to move all of the variable to one side of the equation. It doesn't matter if the variable is on the left or the right, as we've noticed in some of the equations that we've solved already. But to move the variable to one side of the equation and then move the constant to the other. The constant, of course, being numbers. So you end up with, say, x equals 10 or whatever the case may be. So that's your goal. Variable on one side, constant on the other. So it makes these equations relatively simple. For example, in example number 1, we have the constant 8 plus the variable 4 times d equals the variable 5 times d. So we have the same variable on both sides of the equation, d. The general rule that I would suggest that you use is that you always eliminate the smaller variable first. The first thing I want you to do is go after the variable, because in a couple of problems we're going to have constant on both sides and variable on both sides. I would always attack the variable first, and I would always do it by removing the smaller variable. The reason for that is simple. If we were to subtract 5d, which would be perfectly okay in this case, it introduces two problems. I'll do that on a sample here. If we did 8 plus 4d equals 5d, if I subtract 5d from both sides of the equation, I end up with 8 minus 1d equals, and this is what would goof a lot of kids up because you have to carry down the 0 here. A lot of kids would just say 8 equals negative d, which of course would not be correct. And then of course you could move on from this and you could solve the problem. But the best way, by far and away, in my opinion, is to go after the lower variable first. By doing so, you always end up with a positive variable. That's the other thing. Let's say that we were going to remove, if we removed the 5d, we end up with a negative d. Now we subtract 8 from this side, we have a negative 8 over here, and it brings up all kinds of problems with sign. You can avoid those problems by always removing the smaller variable first. So here we go. We're going to subtract 4d, because it's an addition of 4d we need to subtract. And notice that I put right on here as a reminder, include the variable. I often see when people do these problems, they put minus 4 from both sides. You're not subtracting 4 from both sides, you're subtracting the quantity 4 times d from both sides. So we subtract 4d from both sides, we end up with 8 on this side with our constant, and we have 1d, so we're done already. And of course check it. So put 8 in for d. 4 times 8 is 32, plus 8 is 40, and this is the way I would recommend that you do these problems. You write that number up here, and then you go 8 times 5, because d is 8, and that also is 40. We have good check. Okay? We'll move much quicker now. Example number 2. 6n minus 1 equals 4n minus 5. Look for the smaller variable. The smaller variable is 4n. It's a positive 4n, so we need to subtract 4n to get rid of it. Subtract 4n here. We carry down the negative 5. We have negative 5 on this side of the equation. Subtract 4n from this side of the equation. 6n minus 4n is 2n, and we carry down the negative 1. Do not forget the signs when you're doing these types of problems. And now, of course, we're done with the variable. We've got it on one side, so now we want to get the constant to the other side of the equation. So the way to do that is to get rid of this subtracting of 1 by adding 1 to both sides. We end up with 2n equals negative 4, and now it becomes a problem that we're very much familiar with. We just divide both sides by 2, and we get n equals negative 2. Check your answer by putting the negative 2 in here. And we have 6 times negative 2 is negative 12, minus 1 is negative 13. 4 times negative 2 is negative 8, minus 5 is also negative 13. We have a check. Please press pause and do letters A and B. Example number 3. We have 50 plus 30s equals 250 plus 10s. Smaller variable, it's addition. Attack it by subtracting that same amount. Subtract 10s from both sides. This is now gone. We have 250 on this side. We bring down the 50, and 30s minus 10s is 20s. And it is positive, so we are adding it. We now need to get rid of the constant on this side. By doing that, this is a positive 50, so we need to subtract it to get rid of it. And we end up with 20s equals 250 minus 50, which is 200. Nice, easy math to do in the head here. We're going to divide both sides by 20. And we have 200 divided by 20 is 10. So we have s equals 10. Check that answer in your solution. Please press pause and do letter C. I will tell you that this is a challenging problem, but you're capable of it. Just keep using the exact rules as I've given them to you, and you will be able to do it, I'm confident. Otherwise, you can check your solution later. Example number 4. We have 2/3 x minus 1 equals 9 minus 1/6 x. The key here is we have different denominators for our fractions. So we need to end up with a common denominator because we're going to be adding or subtracting the variable. So we want to change 2/3 x into 4/6 x. Now we have a problem that we can easily do. We have 4/6 x and negative 1/6 x. The way to get rid of that, this is smaller. Negative x is smaller than positive x. So we're going to get rid of the negative one first, or the smaller one I should say. Add 1/6 x to both sides. This is gone. And we have 4/6 plus 1/6 is 5/6 x. Subtract the 1. We have 9 here. Add 1 to both sides in order to get rid of this. And we end up with 5/6 x equals 9 plus 1 is 10. And the next step, of course, is to multiply by 6. This is exactly what we learned a couple of lessons ago. Multiply by 6, and that eliminates the denominator. And we have 5x equals 10 times 6, which is 60. Next step, since we're multiplying by 5, is to divide by 5. Divide both sides by 5, we have x equals 12. Again, put this in the original equation and double check it. Please press pause and do letters E through F. F is also a challenging problem, but again, I think you're perfectly capable. Just keep remembering the steps. Here are your solutions to the letter problems for lesson number 4. Our first problem is 8a equals 5a plus 21. Attack the smaller variable. It's positive, so we're going to subtract 5a from both sides. 8a minus 5a is 3a. And these two cancel each other out. 5a minus 5a is nothing, so we have 21. So we have 3a equals 21. Obvious step is to divide both sides by 3, and we have a equals 7. Check that in your original equation. 7 times 8 is 56. 5 times 7 is 35, plus 21 is indeed 56. So we have a good solution. Problem letter B. 3x minus 7 equals 8x plus 23. Lower variable is the 3x, so we subtract it since it's positive from both sides. Carry down the negative sign here. We have negative 7 equals 8x minus 3x. That's 5x plus 23. Obvious step is to get rid of the 23 because that's the variable or the constant on the variable side. We undo it by subtracting 23 from both sides. Negative minus negative is even more negative. We can add them up. 23 plus 7 is 30, and it's all negative, so it's negative 30. And we have 5x on this side. Divide both sides by positive 5. Negative 30 divided by positive 5 is negative 6. Put that into the original equation. Use a calculator, do the math, and it does check. Okay? Letter C, solution. Okay, this is an interesting problem. They ask for the dimensions, so we know we're looking for length and width. So those are going to be our two variables, length and width. They also tell us that the perimeter is 14 more than the width. So putting that into an equation, we can say that P for perimeter equals 14.4 plus W. This is one way to state perimeter in this particular problem. They also tell us another thing about it. They tell us that the length is 3/10 less than twice the width. To put that algebraically, we could say that length L equals 2W twice the width minus or less than, so L equals 2W minus 3/10. Okay, but now we still don't have this in a situation where we can have an equation where we have variables on both sides. So we could take a look at this a little bit and think it through. And we know another thing that we should know in 8th grade about math is that the perimeter is two lengths and two widths. Okay, so twice the width plus twice the length will give us the perimeter. So now we can focus on this. We can replace the two lengths with 2 times 2W minus 0.3, because we know that right here. One length is 2W minus 0.3. So if we take two of those, we can add those up and say that 2W and 2W is 4W, and subtract 3/10 twice would be like subtracting 0.6. Or you can take a look at this if you understand the distributive property and say that 2 times 2W is 4W, and 2 times negative 0.3 or 3/10 is negative 6/10. So now we can replace this, okay, with in this particular spot in the equation. So now we can say we know that the perimeter up here, perimeter is 14.4 plus W. We also know that the perimeter here is 2W plus 4W, because this right here can replace this, 4W minus 0.6. We now have W, W, and W, only one variable. Up here we had multiple variables, so we couldn't solve the problem yet. We only have one variable and some constants. We have variable and constant on both sides. So it's time to solve that equation. So taking that equation, we take 14.4 plus W equals 2W plus 4W minus 0.6. Well, the first thing we should do here, sometimes kids will look at a problem like this and they will subtract 2W from both sides, or subtract W. You don't want to do that yet. You want to combine these first, okay? So that you only have one variable on one side, one variable on the other side. Okay, and of course 4W plus 2W is obviously 6W. So now we have a little bit different equation here. Now we can look at the lower variable, which is 1W. Subtract W from both sides, we get 14.4 equals 6W minus 1W. If it helps you to put the 1W in there, by all means do it. 6W minus 1W is 5W and minus 6/10. Since we're subtracting 6/10, we need to get rid of this constant on this side of the variables. To do that, we need to add that same amount. Add 6/10 both sides. We have 14.4 plus 6/10 is, oops, I flipped sides here. Sorry to do that on you. We have 15, and then 5W is on the other side. Don't worry about doing this in this case. This is perfectly acceptable to flip them because most kids are more familiar with this. Divide both sides divided by 5, and we have W equals 3 feet. So now we know one thing. We know that the width is 3 feet. We were asked for the dimensions, which means we need to find out the length as well. Well, you remember back before we were given this equation that the length equals 2 times the width less 3/10. Remember that statement? So now, since we know the width, we can put that in. Length equals 2 times the width, which would be 6 minus 3/10. And 3/10 less than 6 would be 5.7. So we have a length of 5.7 feet and a width of 3 feet. And all I can say is, wow, I'm really kind of impressed if you managed to get this problem correct. If you did this problem in an alternate method, I would like you to talk to me about that, and perhaps we can have you shoot, or I can shoot a video to show it a different way. I'm really kind of surprised that they put a problem this challenging in the practice problems. If you did it, great, congratulations.